Well, hi, good morning. Thanks so much for joining me here. Okay, so I'm back to this radio. I've had a few little side projects the last couple of days, but I'm back at this radio. And where are we on it? We have a whole bunch of paper capacitors sitting in here that probably should go at the same time. This radio is working really, really well. The capacitors I did take out so far, the paper ones I just threw in the garbage a moment ago, the paper wax capacitors proved to be leaky when I did testing on them, so that would make me suspicious that all these are also leaky too and need to go. And so I was just trying to figure out what order to do these in that might be fun, interesting, and revealing when I noticed something, and that's why I started the camera running, to show you what it is I noticed. Here, have a look. Take a close look. So you see this batch of big, physically big capacitors here. These are all attached to a common ground. Okay, so you should be noticing what I've noticed already. What's that solder doing there? If you look at the other side, especially this big one here, go down and look at it. You see the solder, the way the solder is? There's a good view of it there. So that's a replacement. Now, I wanted to look at the rest, and I thought I'd just use the camera here. So this one's a replacement here. Let's see if we can spot. Hard to see in there, isn't it? You can see if I can get a little more light in there. Well, you know what? That could be. Oh, there's a crack in the solder right where that wire comes in there. But oh no, there it is, right there. I'm looking right at it. You can see the wire-to-wire connection. It looks like a layup splice, where they just lay the wires side by side. Let's see if we can look at this one here and see the technique. Wow. Hard to say, but it looks like it's a layup joint. They just laid the wires side by side and applied solder. Okay, what about this one here? Let's track this one back here. See, you know, that could be resoldered too. Hard to know for sure. So my guess, though, is that certainly this one, you know, these could be cut for testing purposes. That's always possible, that somebody cut this free to perform a test and then soldered it back afterwards. Let me change the focus on this camera. It's a little bit too tight here. Whoops. I almost knocked my other camera over there. Just pull this one back a little bit. There we go. Yeah, that's a little better. So there's a fairly high wattage resistor here with the paint off it. A little bit suspicious too. So let's look at the sort of the vintage of it. If you look at these and we assume these were done, well, they would have been done quite a while ago. You know, this might explain why this radio is working, because in fact the parts that were going to ruin the operation of the radio by getting weak have been replaced. They've been refreshed, so they're old again. That's really disappointing, isn't it? Just because you got refreshed doesn't mean you won't get old again. Holy smokes. So these are probably newer, but if we look over here, we can see what are almost certainly originals, and there's something more about this one that's kind of interesting too. If we look at these two side-by-side guys, I mean, there's clearly a difference between the two of them. This one on the right just looks like it's been run over by a truck or something. Look at it. But here's a really weird part. What's all that? And then look, drip. Now the weird thing about this, I was looking at this the other day and I haven't commented on it yet. So the radio right now, you know, it's on its side, right? I know it's out of focus, but it's on its side. So in this position, this capacitor, if it were to leak out stuff, and really, what would it leak out? Beeswax off the top of it. It would drip this way, like that. But this radio is normally not sitting that way. It's normally sitting, you know, this way. So anything dripping out should have dripped down this way. Hey, what's down there anyway? You know what I'm going to do? I'm going to run out, I'm going to look in the radio cabinet and see if there isn't some of this stuff on there. And then I will run back. Okay, I'm back in a flash in video time. Okay, so I checked out the cabinet. There's a metal plate that covers the bottom of this that's in the cabinet, fixed onto the support board that the radio sits on. And that piece of metal is clean as a whistle. There's none of this stuff there. Here. See? So this raises some interesting questions here. Number one, did this happen to me and while I've been in here? This has been dripping away like this? I don't think so. This doesn't look new. This looks, you know, this is really soft stuff. It's really soft. Well, it's wax, I guess, eh? Or did this happen when the radio was in this funny position on the last guy's bench? I don't know the answer. You know what? I think we're going to go after this capacitor next. I might as well do the two here next. We'll get rid of these two. We'll get a better examination of this one. All they're doing, they're just using a ground terminal right here. They're just like a lot of capacitors, you know, they find their ground terminal wherever it's convenient. So that's what's going on here. Now, where are these in the circuit? That's an interesting question too. So they're going to ground, and it's really hard to see, but it's on one of the terminals of this IF can. Take a wild guess here quickly. IF can. Okay, so there's a capacitor right there going to ground, and right off terminal. Here's another one on the other side doing the same thing, going to ground. I wonder if both these capacitors are those two capacitors, and the answer is yes. Both of these go to ground here, and each of these leads goes to a different terminal on this IF can. So that's what they're doing. So that's interesting. This fits with my plan to move back through the radio capacitor by capacitor and see what happens as we clean it up. So I would think if these capacitors are leaky, that would cause very big performance issues in this radio, and would also, if they're leaky enough, this one here would pull down the AVC voltage, I think. Yeah, because the AVC is coming across here. It's isolated with this great big resistor from the detector, the low impedance detector. So on this side, it's a very high impedance. So you have even a little leak, like even this capacitor. Here's another one. This is a critical one here. This guy is supposed to be silencing the whole AVC. I got to go after that guy too. Very importantly, I'll probably do that one next. There's another one. Oh, bypass it. I did that. Didn't I do that? Did I do that? I think I did that. I did that. So we'll go here. Right on. These two. Okay, enough. I know what I almost said I know what I'm doing. Okay. I'm going to cut these guys out and replace them. I'll do it off camera, and then we'll test these two guys. It'll be easy to keep them straight. I'm going to turn the camera off just a little bit early. So I got them out here. Made in Canada. This is a capacitance is hidden right now. See how they're stuck together too? You can really see the difference. So this thing is really, if there ever was a capacitor that appeared to overheat it, if there's ever been a capacitor that appears to have overheated of this sort, this is one for sure. Okay, still can't quite read the capacitance here. There it is. 0.05. This guy's probably the same. 0.05 right there. So 2.05s, 600 volt capacitors, and then we'll test it. I mean, how bad can it get? It can only get so bad, and then once it reaches a certain level of badness, it really can't get more bad than that. Okay, let me carry on. Hey, you know what? Let's keep the camera rolling. Let's test these two guys right now. Why not? Test them right now. Keep the camera rolling. So this is the better of the two. There's a lot of wax on these wires. Hopefully that's bit in there. So we're on 25 volts, so we're going to put 25 volts of pressure on here. Watch the eye. It should close and open. Close and open. And it did it not instantly, it did it slow enough that it tells me this capacitor actually charged up. That's not too bad. Let's give it 150. Okay, so that's not so good now. It's really not opening at all. So capacitor is not the worst in the world, but certainly not like a new one. Now we'll take this ugly one here. Okay, 25 volts. Let the games begin. It's exactly the same as the last one. 50. It's very, very similar to the last capacitor in terms of leakage. Certainly worth changing, but not, even though it looks, wow, not much different than the other one right beside it. Looks can be deceiving. Goodness knows. I mean, all this wax may have just kind of come off the outside of the... I should keep that. You know what this is going to do? This, wherever you put this, it's going to flow and make a mess. So I'm going to put it in the garbage there. So that wax may have come off the outside, but the only way it could have come off Yes, Peanut. What do you want? Peanut. Are you looking for me to take you outside? I can. Which way do you want to go? Out? Which way is out? Peanut. Peanut. Pay attention here. Which way is out? Can you show the viewing audience which way is out? That way. Okay, so he's looking at the garage. You just came from the garage. Okay, I'm going to take him to the garage. Watch. Come on. Okay, it's a, you know, there's never been a cat experiment that's ever worked, but there we go. Okay, sorry for the diversion. They want to go outside, but it's been rainy, so it's still too wet to let the cats go out, but they'll be able to go out very soon. So where was I? Oh yeah, I tested the capacitors. Now we're going to put in a couple of new ones, then we'll play the radio, and we'll see what happens. In the meantime, I'll bet you I'll be forced to let the cats outside. Okay, what's going on here? So, a little aside, I was getting ready to install these new capacitors, and I thought, hey, I should really try to identify which one of these leads is connected to the outside foil on here, assuming this is constructed in a similar way to the old style capacitors. And it's a bit of an assumption on my part. I imagine it's just coiled up foil inside here. And so one part of it is going to be on the outside. It's going to be connected to one of these two leads. The old style capacitors, they tell you which one it is. So they put this, it's hard to see on this one. They put a bar here and it says outside foil right on it. So I know this is the lead that's connected to the outside sheet of aluminum or whatever's inside here. Foil, just say foil. And it's much better to connect this to the low impedance side of a circuit you're working on, especially a ground point like this one. Well, it's connected to this ground point here. So the reason for doing that is to reduce interference. The capacitor can act like an antenna. If you put the outside foil onto the high impedance side of things, then you're just that much more susceptible to picking up signals in that. So I thought, hey, why don't I, since I don't mark it, let's see if I can identify it. In the middle of doing experiments here, which were not going well, I encountered something else I want to show you. So look, it's just a regular capacitor. It's just hooked up to the scope leads. That's why you see the display on the scope. And nothing special going on here at all. And we'll get rid of that. I just put it here on my bench. This is what I noticed. Bet you it doesn't work now. I had a little bit of a bigger display there before. Let me switch this around. This doesn't make a lot of sense. Yeah, it does actually. I'm putting the live connection onto the outside foil. It's just laying on my bench. First of all, you can see the display is bigger. So here's the thing. Sure, if I get my hand close to the capacitor, you wouldn't be surprised if it did something. Oop, I touched the lead there. So I got to touch the actual capacitor to get it to. So if I touch my bench, my wooden bench, touch it underneath. Right underneath the capacitor here. Here, I'll do it so you can hear me. A little bit of a difference. The closer you get, how about more hand? Less hand. Well, I don't know what to make of that. Part of my experiment was make sure this was not any kind of conductive contact with the wood surface. There you go. Okay. Explain that one. So, you know, with this kind of stuff going on here, I never noticed this before. I don't know what it means. I don't know anything. I just know, look, you can see it happening. How much of the time when I'm working on a radio is weird stuff like that going on that you know, I'm just not sensitive to. Incidentally, I could not pick. Hey, let's try it again. I could not find the outside foil. Let's try it once more. Okay, so you see the display on the scope. It's about a ½ centimeter there. Now I'll reverse these leads. So this is not quite connected. And that's about, well, it might be slightly bigger. Unfortunately, it's right at the limit of the scope here. Yeah. Let's just line it up carefully. So measure that. Oh my gosh, I'm touching the controls and it's causing that same effect. You know why? I know why. Look, I had my hand like this. Is that really the case? Oh my gosh, okay. So let me touch the scope here. I'm grounding myself basically. Okay, I'll take my hand off the bench. Oh my gosh. Put my hand back on the bench with my finger on the ground. Take my hand off the ground. Oops, I was touching another grounded thing over here. What if I touch a... Hey, let me touch something that's not actually... It's a two-pronger. Okay, this guy here I think is a two-pronger. Oh! Okay, just get the whole picture here. I got a hand like that. And I'm touching this. Like that. Well, you can see what I'm doing. Okay, so I will energize myself by touching the poorly grounded box here of this. And now I'll take my hand off the bench. And now I'll untouch the box and touch it. Maybe a touch, maybe a little bit of difference there. But wow, look at that. Okay, I'm gonna leave it at that. Who would have thought my wooden bench somehow enters into the game here? I just sort of assume, man, you're working on a wooden bench. Can it get any better? Oh my gosh. Another strange lesson learned here. Let me just fix the video. One moment. Okay. Now, it could be they don't mark the outside foil because there isn't one in this capacitor. Maybe there's something about how it's constructed. So, couldn't find any difference either side anyway with my fooling around. So we're going to go ahead and put them in and check out the radio. Try not to get distracted, Jim. Okay, I got the two capacitors in there, and I'm just looking at this and thinking about these two capacitors who are kind of doing the same thing, but under different circumstances. So their job is to make sure the bottom of these two coils here are RF grounded to the chassis through the capacitors. That's why they're fairly large, 0.05, so that's pretty large for high impedance circuits. And both of them, like there's one here and one there, I mean they look to be identical in terms of their place in the radio, yet one of them appears to have overheated. It certainly looks that way to me. Why would one overheat and the other one not? And the answer is pretty obvious. This guy has no pressure on him. He's operating the circuit to the grid, which only has a few volts, a couple, 5 volts. There's no pressure on this guy. This one, on the other hand, has to tolerate B+, which is going up to the plate here. So this guy has got to withstand a couple 150 volts. And if it can't, because it's leaky, guess what? It's going to get a little hot. Now, you know, one of the side issues with this radio is the speaker gets hot. The speaker gets hot because the field coil appears to be working too hard because something is drawing too much current. And we could be talking about just a couple milliamps here. Too much current from the high voltage supply. Was it that capacitor? I don't know. But it's all interesting stuff. It's interesting stuff to think about. Okay, let's fire up this radio. I'll put the antenna on after it's operating. Okay, we're on the AM band. Volume down. It's plugged in over here. And we'll make sure we put it on with the dim bulbs. Here we go. Okay, so the dim bulbs have behaved properly. Give the radio another moment. Here we go. Full voltage. Volume up. Of course, there's no antenna on it. Let's put the antenna on. Bearing in mind now this is a loop antenna with a strong signal, strong output. Okay, what do we got?
Execution. Also today in 1940, Alsace-Lorraine was annexed by the Third Reich, part of Hitler's slow, steady march towards war. Well, of course, war had already broken out in 1939. By 1940, of course, the Germans had overrun Alsace-Lorraine, and now that area that had been annexed by Germany after the Prussian-Franco War and then taken back by France after the First World War was taken back again by Germany. A piece of land goes, and so
That's the no.
Go back and forth in terms of nationality, and there's a number of places. You think of some of the islands
Aimed
around
at
Greece
Toronto.
and Turkey, and after
Actually, you
the
know what? I
First
think
World
this is
War, there were mass changes of
640.
immigration. People
Yeah,
were
I
like,
think the
okay,
antenna's in
you don't live
Toronto.
in Greece anymore. Now you live in Turkey, or if you want to
Hey,
be
let's
Greek,
try something else.
you got to
Let's
move.
try 680. 680
Nope.
this way. Lots of volume. Okay, let me just tune the antenna.
Check out Tubley's Farms, new patio and bar, new menu, new area to visit the animals, and more. Extended hours on Fridays and Saturdays for summer cider nights. Details at Tubley's.com. With the forecast meteorologist Jill Taylor.
Some sunshine, but most of the GTA will stay mainly cloudy today. Still on the muggy side, the guaranteed high 28 will feel like 35. Partly cloudy overnight, morning low 19, and then showers or thunderstorms. Tomorrow afternoon, the high about 26. Slight chance for some showers for Thursday and 29. Again, feeling a bit warmer with the humidity. Right now, it feels close to 30. Actually, humidex is to 30 at Pearson. It's 31 downtown now. 23 degrees at the airport.
Can't hear any effect from this bass control, but then I don't have the speaker in its cabinet and all that, so.
680 News, time 9:13.
Now, the moneysense.ca market minute.
Over to Mike Epple at the 680 News.
Let's try the other end of the band here. Now, this is tricky. I have to go tune the antenna. Okay, we'll just stop there in a quiet area. When I tune the antenna in, you'll know it. That's how you'll know it. Let's see what we can find right around this frequency. No, I'm using a loop antenna. It's still lots of noise. No, we're not going to pick up anything. Just reorient the antenna. There's a station up here. Okay, apparently that process kind of killed my antenna over there, but that's okay. Not to worry. Just the pin came out of the bottom of it. So radio's actually performing not bad. I think its performance can be better. And you know what? We really got to give it a go on shortwave here. We just have to. On a counter. That's the kind of person I am. So let's get the cord I need. It's right here already. Great. Put this guy up. What are we going to hear on shortwave? This time of day, the usual thing is there isn't much to hear, but let's find out. Okay, we're on the shortwave band. We're on an outdoor antenna. What? That's very odd. There seem to be 2 points in the band where it kind of quiets down a bit. So question is that chugging, or chugging I guess you could call it, is it coming out of this radio or is it coming off the antenna? And if I change the supply voltage to the radio, this clicking, if it changes, then I'll know it's from the radio. So I'll drop it onto the dim bulbs again. Okay, getting quieter doesn't count. Looking for a change of speed or the tone of it. I don't hear it. Okay, and another thing we can do is we can try another radio. Why don't we try that? Okay, so I haven't run this radio for a while, so let's give it a go. It's this one up here. And we're on the shortwave band. We're up around 12 megahertz here. Let's see. That would be right up around here. And okay, so that's actually hooked up now to the same antenna. So I don't hear that sound. What the heck is that? What the heck is that? So power. Oh, you know what? I bet you it's a local oscillator from this radio. Let's see. I'll tune this old radio here. Oh. Did you hear the feedback? Stuff I do. Oh, it's another feedback. Trying to pick up any shortwave that I can. Finally, something. Just below 14. Oops, let me turn it off. Just below 14. Okay, your turn. So, antenna. That white wire. Right here. Well, isn't that interesting? Learn something new every 2 seconds in this shop here. Hey. Hey, how do you like that? Wow. Okay, what do we got? Okay, it's still there. So I think I just weakened the antenna is all I've really done here. Okay, hold on. Now I gotta reach back here. Oh my gosh, I thought I was almost done. So that's switching the antenna off. Just switching it back on. Disconnecting it. Putting it back on. That wire is heading up to that other radio. Why don't I hear the same sound? There isn't a hint of it. Yeah, fat chance on this radio picking up that. But maybe there'll be something else in the area of 14. Okay, let's ignore the chatter. Of course, you know, this signal is probably setting up an AVC and just knocking the... Okay, so that's probably the local oscillator of the other radio. The antennas are connected right together, so you're listening to this radio. Respond to that. So. Well, I don't know. Don't know what would cause that. Well, I do know. I do know what can cause these kinds of sounds, but the fact that it's incredibly stable, is not affected by a change in the supply voltage to the radio, is kind of interesting. I mean, radios are designed to be stable with varying supply voltage. The design engineers are really sensitive about the fact that the house voltage goes up and down. So maybe that's why changing it doesn't affect the chatter. Where's the chatter? Bring back the chatter. What about all these tone controls? No. So anyway, maybe once we get rid of all these capacitors, maybe that noise will go. But for now, it seems to be just wrecking the shortwave band. Okay. I think we can call this a wrap for today. What do I got left? 1, 2, 3, 4, 5, 6, maybe 7, maybe, and probably 2 more hidden from view in there that I haven't spotted yet. So about 7 more capacitors to get out of there. Be interesting if the clicky goes away. Thanks so much for watching. Hope you enjoy your day, and I'll see you on the next video. Or you'll see me on the next video.